Hello, good morning, and welcome to this new webinar. Today, giving continuity to the last webinar about the heat recovery unit CAD compact with the advanced controller, we are going deeper in the use of the controller to see how can we configure the unit, which settings can we introduce, and let's say how to play with the controller and how can we get all the powerful functionalities of this controller. Today, in this webinar, I am accompanied by Saul.
Hello, my name is Saul. I work in export department and I am responsible to give technical assistance.
Okay, let's start with the use of the control, but before, it will be good to refresh some concepts related to fan controls in ventilation, which will show better the way we can configure the controller. So I have just prepared these slides. Okay. Well, in ventilation, we can find two different types of systems. Let's say, depending on the room or the zone, we have to ventilate. For example, if we have to ventilate just one zone, we talk about the single zone system. However, if the system we have to ventilate is composed by more than one zone, then we have what we call multi-zone. So with just one ventilation unit, we ventilate more than one zone. This is multi-zone. If we think in ventilation in terms of regulation, then we have two different types of system: variable airflow and constant airflow. So depending on the system type and the regulation we have to apply, we will choose the best system for our case, for our application. Let's start with the most common, which is to have a single zone and the necessity of a variable air volume system. In this case, the ventilation will depend on an external input, which used to be with a sensor, 0 to 10 volts, analogic output sensor. 0 to 10 volts is the most common. However, we could find some system with 420 milliamps. But the most common and the trend seems to go to 0 to 10 volts. This is a system recommended especially for indoor spaces where we have variable occupancy. So the necessity of ventilation will vary depending on the hour of the day. Normally in these systems we have to set the different parameters, which are the minimum speed and maximum speeds, and also which are the input minimum and maximum values. In the case of CO2, this is an example. You can see this example, which could be common in spaces where a higher level of quality is demanded. And this system, we can see better with this graph, will operate at minimum speed with low concentrations of CO2. Below 400 ppm, system will go at 20% of maximum speed, which is nothing, just a valley airflow. And the system will operate at maximum speed, 100% of the fan speed, when we have concentrations of CO2 higher than 1000 ppm. In the interval of 400 ppm and 1000 ppm, the answer of the system will be proportional. Okay, this is a common system, and then later in the webinar we will play with the controller and set this configuration. Okay, in this case, it's always necessary to have an external accessory, which is a CO2 sensor. It can be humidity sensor, so it's a sensor to to read from the indoor ambient the value of air quality. Okay, if we move to constant air volume, well, the components can be similar. So the system is composed by one ventilation unit dedicated to ventilate a single room, a single space. But in this case, the regulation works in order to maintain constant airflow. So basically, here what we are doing is to compensate the filter clogging by increasing fan speed. This is normally demanded in systems where it doesn't matter the air quality. We always have to ventilate with the same airflow because of odors or because of other pollutants that are in the ambient, and we cannot read it with a sensor. Okay, in this case, we can see here the fans curve, and we operate always in this line. So always with the setting of constant airflow, independent on the as commented before, on the clogging of the filters. Okay. In terms of accessories, in this case, and talking about CAD Compact Advanced, not CAD ProReg, it's different. In CAD Compact Advanced, we have to order two separate pressure transmitters to read the internal airflow, which is passing through both fans. So in all cases, you need to order these two pressure transmitters. Okay, and if we go a step forward, complicating a bit the system, we have the multi-zone combined with VAV regulation. In this case, what we have is one ventilation unit which ventilates different spaces, different rooms, and well, so what we have here are different subsystems, as you can see here. For example, a double flow system with a it could be a CO2 sensor, which is measuring the concentration of pollutants of CO2 in the ambient, and is regulating not the fan, but the dampers included in supply and extract duct systems. So we have different regulation systems composed by sensors. It can be CO2 sensor, but also it can be a PIR sensor or detector, or humidity sensors, or different technologies of sensor. But the important here is that the sensor sends the signal to the dampers that are more open or closed depending on the concentration. Well, this system is composed also. Well, here you can see the sensor or the graphic to see the relation between the sensor and the opening of the damper, which at least is the airflow which is being delivered to the room. But in this case, we need also to control the pressure in the fan. So the demand finally is measured by some pressure transmitters. Let's say one pressure transmitter, which has to be fitted in the pressure net where we want to detect the value of pressure. It's important to remark that we can select only one pressure transmitter. So we have to decide where we want to place the pressure transmitter, in the supply or the extract side. And then it is possible to unbalance the other fans with a percentage of the speed of the fan which has the regulation. But important to say that it is not possible to have COP control mode in supply and extract at the same time. In CAD Compact Advanced, we have to decide which is the right one. Okay. Well, this related to control system. We will also see one of the powerful functionalities of CAD Compact Advanced. The Advanced Controller allows to interchange the supply and extract fans functionality. We saw that in the previous webinar, and in this case, we are going to see how to this configuration. It's quite easy to modify that. Just to remember that what we are doing is to interchange all the input and output of the controller in order to make the controller understand that the supply side is on the left or on the right side. Okay, this is related to fans.
We will see that we have 4 different kind of batteries. I will help to explain the different functionalities of them. And also we will see how to set the bypass settings, the Modbus parameter settings, and how to update the controller. Remember that to use the different batteries, we have to order different accessories. For example, the 3-way valve, also the temperature-proof TGK, and the
coil, the same coil. Yeah. The coil.
The coil. And the coil. And for the preheater option, we don't need the TGK proof, and we just need the pressure switch accessory. So now let's see how to, but let's play with the controller.
Okay, so let's start with the controller. So this is the main screen you will see when the unit is switched on. The information you can see on the top of the screen is the set point temperature, the fan speed, supply and extract, and the information related to the main configuration, hour, date, and also the supply temperature and the outdoor temperature. Here below there is a bar with the indications about the fan selection mode. So here we have all the possibilities of settings related to fans. At this moment you can see that this is in standby, but it is also possible to select speed 1, which is maximum speed, speed 2, 3, to load a preloaded setting of schedule, and also to run the unit in VAV mode. Okay. It's important to say that before starting with a configuration, the unit has to be switched off. Well, this is the one of the possible display of unit, but the same parameters are also available in a configuration as a diagram. Here you can see also fan speed, temperatures, the position of the bypass damper, but with this type of visualization it's easier to get an overall view of the unit and what's happening with the main elements. In case we have enable post heaters, post cooler, or a preheater, the element will be shown also in this diagram. Okay, here we cannot modify any setting. With the previous configuration, it is possible to modify the set point temperature. Okay, then if we push this icon here below, we access to the main menu. At this we can move for the different icons, which bring us to the functionalities we have here. It's important, sorry, because this is very sensitive. So one of the first things you have to do is to choose your language, and it's that simple as go here again. Okay. Language, and modify as you want, and all the menus will be changed to your language. Okay, apart of that, I find also interesting to take a look at general settings to information. Here we have the main variables the unit is measured not only inputs but also outputs, and this is organized in 15 different screens where we have all the information that could be useful, especially for the installer, or once you have to fix some problems in one unit which is not giving a good result, or there is some incidents you have to fix. Okay, so main screen is the temperatures. Then you have also the information about the fans, unit status and percentage of maximum related to maximum speed, situation with the filter in case you need to replace filter, the position of the pressure switch, well, the working mode if the unit is in cooling or heating mode, and main temperatures that affect the working mode. Also you have here the fan speed configuration, the bypass situation, the bypass damper. Well, the boost, we'll see how to configure the boost, but here you have the information about the status of the switch and the variables that has been pre-configured, the digital input, the percentage of heat recovery. At this moment with unit switch off it's nothing, but we will see here the efficiency ratio when the unit is running, and in this case if we have a CO2 sensor configured, the information about the ppms and hours of working. And very important also is the versions of the software of the unit. There are two different softwares per panel and controller that can be updated separately. Saul will show us how to upload these software versions, okay, and other functionalities that are not in use. Okay, let's start with the configuration of the fans, which is one of the main purpose of this presentation. So by default the unit is delivered in VAV mode. We have to modify the configuration. First thing is to access to service settings and load the password. There are two different passwords, two different menus of access, installer and factory, let's say. To access to modify the fans functionalities, it is enough with load the first level of access, which is for once. Can push enter or OK, it's the same, and now we are accessing to these parameters. To change the mode is that simple, so access air handling unit working mode by default in VAV, but pushing here we can modify. In VAV there are two options, so we can access in VAV manual and define which speed we want to modify. For example, if I want to have both fans working at maximum speed, so it is that simple. At this moment speed 1 is configured at maximum speed, speed 2 is at 60% of maximum speed, and the 3 40%. And as you have seen before, it's possible to modify supply air fan and extract air fan separately. Okay. And in case of VAV manual, this is VAV auto, what we have are the parameters normally used in proportional systems. We have seen before in a presentation that in this case it's necessary to configure a ramp defining which are the minimum speed and maximum speed here, and the input from the sensor, external sensor, to establish the proportional ramp. So there are the 4 points. If we want to modify the settings, it's that simple. So only access this button and change the value as we want. Okay, and also the possibility to define an offset of the extract air fan compared with the supply fan. Okay, so once the ramp has been configured, we have it. It's important also in case of VAV auto to define the type of external sensor, air quality sensor configuration. By default it comes as known, and we can define a humidity sensor or CO2 sensor. Okay. This related to VAV. Then other possibility, oh sorry, I go out, it's very fast to go back. Other option, as we have seen in the presentation, is to change to CAV, constant air volume. So we push here, and at this moment we have to enter CAV configuration and define the real airflows we want to be maintained. The same as in VFE, but in this case the display is showing cubic meter hours. And the same, we can modify the supply air volume and the extract and fit different values. It's very simple. Okay, and this for all the speeds. So we are defining which are depending on the requirements of each installation and our customer, for sure. In the case of CAV, it's also important to define the information of the pressure transmitters that will be used. And separately, we have to define the supply air pressure sensor and the extract air pressure sensor. In the case of our TTPs, the own pressure transmitter allows to modify the settings, and it's possible to load different pressure ranges in TTP. So the only thing important is to set the same pressure range here that in the pressure transmitter. If we know which is the value of the pressure to be maintained, it's good to have or to select a range that should be about the double of the pressure maintained. Let's say if we have to maintain a pressure of around 250 pascals, the best range to set here and in the TTP is 0 to 500 pascals. This is the general criterion. Okay, and it is also possible to modify the type of outputs coming from the sensor. Apart of the range of the pressure transmitter, we have also to set the value of K factor. This can be found in the manual of the CAD Compact Advanced. For each size of CAD Compact, we have a different value of K factor to be introduced. It's that simple. And the same with the supply air transmitter. Okay, I think that nothing else for regarding CAV. And in case of COP, okay, we select COP, and here what we have is the position, as I commented in the presentation. In case of COP, we have to choose between supply and extract. There is no possibility to control in parallel supply and extract pressure, so we can only select one of these. This is the position where the TTP used to control pressure should be installed, supply air duct. Okay. And if we go to configuration, it's more or less the same as with the rest of working modes, and we have to establish different values of pressure for assigning to 1, 2, 3 pressure, and the possibility to define a percentage of balance for the fan which is not managed by the TTP. Okay. Well, another thing that is common for all the modes is the fan setting. So the unit is from factory is delivered with a pre-configuration that should work in the majority of the cases. But depending on the conditions, the duct system, the distance, the type of dampers used, it could happen that the answer of fans won't be the desired one. In this case, it is possible to adjust the answer or the behavior of the fans by modifying mainly three variables, as is the proportional band, the integral time, and the derivative band. So by modifying this constant, it is possible to modify the behavior of fans. This is a thing to try experimentally while doing the commissioning of the units. In the instruction booklet, you have some recommendations about the way to modify the settings, but it's something to try in the installation, just in case that you see that the answer of the system is not the expected one. Okay, but the system allows, the software allows to modify these settings. Is that simple? So okay, to continue with the training, I will change to VAV. Okay, sorry, VAV, and okay. Important to always go out with okay in automatic. That is. Okay, related to fans, there is also one functionality that is the boost mode. So it is possible to activate an extra speed by means of an external switch or push button. In this case, this is also highly configured, and it's possible to indicate the type of device used to activate the boost mode, and also the speed to load. It can be maximum speed, but it could be a different one, and the time, the duration of the boost, and the type of contact to activate it. By default, it's normally open, so in case of close, the digital input, this is indicated in the wiring diagrams in the manual. So when we close, we activate the button, the boost mode, but it's possible also to change the type of contact. Okay, and sorry again. Other functionality we talked about before was the possibility to change the supply fan side. By default, the unit is delivered with the supply fan on the left, but it's possible to change it, and it's that simple. So access at this channel configuration chapter and change to right, and okay, and then at this moment the unit will interchange all the inputs and outputs, changing the supply fan and by the extract fan. Okay, I let it as by default. Okay, and to finish the part of fans control, we will do a time configuration. To access the timer, you have to press this button here, and you will see that we have here 5 periods of times per day. So it is possible to set different periods of time for all the days of the week, and that times can be different for each day. Here what we have is the day. Okay, and now is the period we want to configure from 8 to 12:30. This is the best way to do this with an example. It's very simple to modify it. So, okay, so from 8:30 to okay, well, what's happening is that there is a previously configured time. Okay, so in this case we have that from 8 to 30, we can assign to this period of time, which is the time 1, different speed. For example, we can do the unit to run at maximum speed, at speed 2, at speed 3, or VAV auto, that will be working depending on the CO2 levels. For example, well, this is already defined, and now once we have the period of time, we can copy this period of time in the different days of the week. For example, this way we are copying the first period to all week long, and once we have done it, it is possible to create a different period of time. For example, it could be so from time 1 was to 1, okay, from 13 to 14. So we could assign a different speed, for example speed 1, to do a high speed for sweep during this period of time. Okay, we have created this new period of time, time 2, and we do the same. So we copy this new period of time in the rest of days. At this moment we have load. We can check it. So if we go to Wednesday, time 2 is the same as time 1. Okay, and the same with the rest of periods we want to create. Okay, so by my side, this is all I want to show you related to configuration of fan behavior. And now it's time to Saul to show us how to configure coils and other functionalities that are also very interesting. As always, remember to stop the unit before changing the configuration of the controller. I will first start explaining how to modify the Modbus parameters. We need to go to service settings, and here note that it's the it's the installer password. Here in Modbus settings, we can set, for example, the Modbus address, transmission speed, number of stop bits, whichever configuration we need to connect it. I will show now how to modify the bypass settings. Now we have to go back again, service settings, and now this is the other password, 1951, bypass settings, and here we have all the different options we have to configure the bypass. So now I will now explain the configuration of an external post-heating water battery. We need to go here to the manufacturer settings, and first we need to select the battery. We go to heater settings, and in this case post heater type and water 0100. Select it. Now we need to set the configuration of this battery. We go to AHU working mode, and now I recommend it to set it on auto. That is because it will be just made automatically. We can set if we want to just to summer or to winter, but if you set it in auto, you can then select at which temperature you want to activate for example, the winter mode. We can set it, for example, 17 degrees or 15, and also we have here the summer mode activated stereosys that will be how many degrees we want to go up to activate the winter mode. For example, just 7 degrees. So then at 20 degrees it will change to the summer mode. Okay, so now we need to go to activate the sensor after exchanger. So we go here and we turn on. Now we need to activate to enable the sensor, and we go all the way up, input output configuration. Now we will assign this proof to one of the analog outputs. We go here, post configuration, out number 4, and we select that this is a post heater. It is also possible to modify the settings of the heating regulation, just for example to set a delay before it starts heating. We will go to post heater settings, and here, for example, we can set a delay of some time if we want to. Here, just to have some time before I start the heating. For example, if we want to set another battery, it will be the same. It's really simple. Just for example, post heater setting.
we will go here to heater settings and select, for example, an electric battery. Just have in mind that for an electric battery, it is not necessary to have approve the TGK enable. If we want also a preheater, the same. Heater settings. Sorry. Heater settings, preheater type. Finally, to update the controller, it's just really simple. You will need to introduce a micro SD from the back of the controller, and when it's inserted, you will need to go to General Settings and to software update. Then it will automatically detect the software, and you will need to choose between update the touch panel or the controller. Here, if we want to see all the different configurations that we have, we will go to this screen and we will see that we have set the post heater battery as installed, and we could see also if we have set it a preheater. And that's all that we want to explain to you. Let's pass to the presentation.
Okay, so we hope you have found the content useful, and thanks for attending, and hope to see you in next webinars.
Bye bye.
Bye.